Welcome to this video lesson on displaying quantitative data with graphs. After today's lesson, you should be able to make and interpret dot plots, stem plots, and histograms of quantitative data. You will also be able to identify the shape of a distribution from the graph, describe the overall pattern, shape, center, and variability of a distribution, and identify any major departures from the pattern, such as outliers, and compare distributions of quantitative data using plots, stem plots, and histograms. The first thing you will need to do is open up the file in Canvas that has all of the data in it. And we're going to use those numbers. The first question, the numbers of pairs of shoes, is this a categorical or a quantitative variable? Last week we talked about categorical. We talked about they have labels versus quantitative, which is a number. We're not talking about who has what kind of shoes. We're talking about shoes overall and how many people have. So this is a quantitative variable. I would like you to go to Stapplet.com and make a dot plot, a stem plot, and a histogram by entering the data. You are going to choose the one quantitative variable single group to enter your data. Include your variable name, which is how many pairs of shoes do you own. Your input is the raw data, and you can just put the numbers. You can either put a parentheses between them or not. Copy down the graphs when you have finished inputting your data. All right, now that you have all of these copied from Stapplet.com, I want to give you a couple notes on these so we can talk about them. One thing you want to be sure is you want to be sure to label. So I would use a different colored pen to help you draw out your notes when you go back to review. So be sure to label. So here, I have the scale, I have the dots, but I didn't say what I was actually doing. So this is the number of shoes owned. I should have included that. All right. So this is our dot plot. We've done a couple of these already in class. This is called a stem and leaf plot. The stem is the beginning of the number and the leaf is the second part of the number. So in our data, we had the numbers 3, 3, 4, 4, 4, 6, 8, 8. Well, if we were going to write them as a two-digit number, it would have been 0, 3, 0, 3, 0, 4. Then we had a whole bunch of tens. So this is 10, 10, 10, 10. This is the left-hand number, the two-digit number, and these are the right-hand numbers. So we've got all of our numbers represented here. So this is very important. You have to be sure that you include a key. If you do not include the key, you will lose points. Must have key. It's on all of the AP Stats reader rubrics. So I want to make sure we start including it right from the very beginning. And then we have our histogram. So the histogram is interesting because it has what's called a bin. So this bar is called a bin because inside of this bar is any number of shoes owned between 0 and 10. I know there are 8 people who own between 0 and 10 pairs of shoes. That's all I know. Okay? So I didn't label this one too. Number of pairs of shoes. So on your histogram, you cannot see the individual data points. So you cannot see individual data. It's very useful. You can see a lot with it, but you cannot see the individuals. You can't see the individual data. Okay? But we can see shape, and that's something that's very important. We're going to talk about that in just a second. In our dot plot and our stem and leaf plot, each one of these dots represents an individual. Each one of these numbers represents an individual. So you can see the individuals. That might be important depending on what kind of summary statistics we want to do. You can see the individuals, and you can see the shape. But this would be terrible if we had a large data set. So it's not good for a large data set. So to compare, we see each and every answer in the stem and leaf plot and the dot plot. In the histogram, they get lumped together in a bin in one of these bars. So you can't see the individuals, and you can see shape. And this is just fine for large data sets. All right. So before we talk about shape, outliers, center, and variability, I want to give you a few notes to kind of get you started. You have probably talked about some of this in previous stat units in your classes. So shape, when I say the shape of the data, there's three major shapes that we're going to talk about. One we have talked about already was this nice symmetrical shape. And the other two shapes, we have one where you're going to have the lump more on the one side, and then you're going to have one with the lump more on the other side. So these shapes, they're askew. Both of these are skewed. This one in the middle, over here, this tail is on the right-hand side, so we call this a right skew. This one, the little tail is on the left, so we're going to call that a left skew. One of the things I do to kind of remember that is I kind of envision this as a whale. Do you see him? Here's his little tail. Eyeball. He's a happy whale. He spouts water. Okay. Where the tail is the skew. So your tail is the skew. Okay. So let's look at our data up here and see if we can determine which one of these shapes our data is. If we were to take and just draw a very smooth curve over our data, that's what it looks like. Okay, let's try it again. We can still see it on the stem and leaf plot. We've got to turn this one sideways to kind of get an idea. Here we go. There's his curve. And even over our histogram, if we draw our loose curve, there it is. On all three of those, the tail is on the right. So if the tail is on the right, we're going to have a right skewed. Okay? So you're just one of these three major shapes. That's what we're really looking for here. Outliers. So we're going to learn a rule about outliers shortly. But right now, I just want you to look at the data and see if it looks like anything is farther away from everything else. So when we're looking at this dot plot, it's kind of nice to look at that because you can see the individuals. These two dots here are a little worrisome, these two data points. So I'm going to say, I'm not going to say they are outliers because I don't know that for sure. I'm going to say potential outliers. And I'm not going to just say that. I'm going to say at, then what are those 2 points? 37 and 41. Go ahead and name what you think they are. All right. So now your center. Your center is your mean or your median. So if you go back and look at your Statlet data, it shows you your mean and your median. So your mean in this case is 13.08. And the median was 10. Okay, so those are two different numbers. Generally speaking, if our distribution is symmetrical like this, at this nice bell-shaped curve, you would use mean. But ours is not symmetrical. Ours is skewed right. Anytime you have a skewing, you want to go ahead and refer to the center using the median. So this is the one we want to use if we were going to describe where the center was. Now your variability, for right now, we're going to talk about range. Your range is your max minus your min. Your biggest number minus your smallest number. If you look at your Statlet data, you can see that they don't tell you what the range is, but they tell you the minimum number, and they tell you the maximum number. So you can subtract and you can find out that the range is 38. So alone, this doesn't really tell you anything. This really comes into when you start to describe two different distributions. So I want you to be very careful. We don't want to be super definitive. So up here we said right skew. I want you to think of things like ly words, okay? I want you to think maybe we should have written slightly right skewed, okay? So we want to kind of hedge our language a little bit. Here we hedged it potential outliers. We didn't say there were outliers. We just said there were potential outliers. Another thing I want you to make sure, if you're comparing two data sets, you need to use comparison words. And those are generally words that end in ER. Bigger, smaller. Those kinds of words when you're describing this compared to that. All right, you don't want to just do a laundry list of this distribution shows this and this one shows that. You want to compare the two of them together. All right, so which of the three types of display do you prefer and why? That is completely up to you. And you may prefer different ones for different reasons. I almost never pick the stem and leaf plot. That's my personal preference. I don't like to, I think they're a little more cumbersome. I think the dot plots are pretty good, but for really big data sets, I like to use the histogram.